Hello friends, welcome back to my Python series. In my last video I talked about miscellaneous program and I demonstrated how list of dictionaries is going to work. In today's video I will be talking about list of lists. As you can see right over here, the nested list object holds a list where each index again has got inner list. Just like the way in case of list of dictionaries where we have got inner dictionary and the outer one was a list, the same way here also the similar thing is happening. The inner one is the inner list that is present in each index of the outer list. Just like my list of dictionary, I said that the student object will stay inside the stack memory, whereas the dictionaries will reside in the heap memory. Here too the same thing. The object nested underscore list will stay in the stack, and these inner list will all be kept within the heap memory. Do remember, Python follows automatic memory management and garbage collector for clearing the objects when these objects are not in use. Let me run the code and let me show you how this address are all been shown over here. As you can see, this is the address of the nested list object which is present inside the stack, and in each index, because you can see right over here I'm pointing the index, so each index will print the address of the respective inner list that is present inside the heap memory. So this address is the first inner list present in the 0th index inside the heap memory. Again, this is the second list present in the 1 index of the nested list object, and these are all present inside the heap memory. That's how the thing actually works, and we are printing the address with the help of id function, which is basically going to pinpoint the memory address of a particular identifier or a particular object that resides in the memory, and the memory can be both stack as well as heap. Okay, and as I said, Python follows automatic memory management and garbage collector. So once we have seen the address, now let's move on to the next piece of code. What we are doing over here, we are printing the entire list, and that's the reason why you can see the output exactly like this. So that means this is my complete list. In the 0th index of the iteration, it picks up the very first inner list, stores inside this row, and it is as a whole. So here it gets printed as a whole. Again, from the inner list object, it picks up the second row, and that row is been kept right over here, and that is what get added over here, and that's what is getting printed right over here. In the same fashion, again the third iteration, it picks up the second list from the nested object, and then it gets printed right over here. So that's how you are seeing index wise each inner list individually. Follow my statement. In each iteration, it is picking up an entire inner list, and you are seeing the complete list as a whole. Okay, and this concept will be further modified when we come to the flattened view concept. We'll come to that part at the end. So we saw how to print the entire list that is referred by the nested list. But what if I want to change any one of the item? Yeah, you can do that straightforward, because list follow indexing. So ordering is possible in case of list. So I can target a particular inner list and a particular item in that inner list. Like over here, see, I said nested underscore list within third bracket 1. So this is 0, this is 1, right? Now this 4 is actually 1 of 0, and this 5 is actually 1 of 1, and this 6 is actually 1 of 2. So that's what I'm targeting. I'm changing 6 to 99. So 1 of 2 is getting changed off. Row number 1 and the item number 0, 1, 2. That's the thing. So when I print it back, as you can see right over here, the updated list is actually printing the modified value. So that's how you can target any item within the list and through the help of index. And then we are printing the updated list once again to see that yes, update took place successfully. Now I want to insert a new row, and for that reason I will go for append. So with the help of append, out of the initially there were 3 in a list, and now we have got one more added over here. So altogether there are 4 in a list. And remember, when you're adding this, again this inner list will be stored inside the heap memory. All the inner parts are going to be stored inside the heap memory. Only the reference would be stored in the stack memory. Fine. Okay, and now just like the way I showed you how to edit a particular item, in the same way I can print the data also. So this is 0 index, this is 1 index, this is 2 index, and this is 7 is 2 of 0, this is 2 of 1. So I want to print the item 2 of 1, and that is 8, and that gets printed successfully right over here. So it's a row number 2, item number 1, or column number 1, you can say so, and that's how the item got printed. I believe after this you understood that how we can insert a new row, how you can edit a particular item, and how we can print a particular item. I hope you understood. Now let's come to the portion of kind of search operation. Okay, we are performing a search operation. Now let's consider this one. So over here I wanted to check whether value 5 is present in this entire list or not. That's why I want to do it. So I create a new variable called value to check is 5. Okay, again, in this entire video I'm not taking user input because I want to show you all the different principles that a list actually going to follow. And this miscellaneous entire series, these portions are all of this format where I have taken the data directly, and I just want to show you how to perform different operations, because in my previous videos at the very day 1, day 2, I've shown you how to take input. If you follow that approach, it would be quite good. Just to save time, I'm doing it in this fashion. So over here what I have done, I have taken a value 5, and I want to see whether this value 5 is present inside this list or not. And how do I do this? Well, I'm not following the regular for loop, and inside the for loop if condition, I am not following those approaches. Rather, I'm doing it in a bit different way, and this is what actually that's what makes Python so special. Look at this very line. Yeah, I know it might be confusing initially and you might not be able to follow how it is working, but I will break down the entire statement part by part. So what I'm going to do, I want to check whether value 5 is present inside this list or not, and I want the answers to be in a boolean form, true or false. If it is there, the output will be true, and if it is not there, the output will be false. As you can see, 5 is present twice, so don't expect the output to be true 2 times. It won't be like that. Even if it 1 time, then also it will be single true. If it is n number of time, then also it's going to be single true. Okay, so how exactly it's working? Let's start from the back. So what you see over here, we are performing one iteration, isn't it, for Sn nested list. So this is my nested list, and I'm performing iteration just like the way I did few minutes ago right over here. See, nested list for row n. So just imagine the same thing I'm doing. So what does this mean? It will pick up the 0th index, that is the first row, and it will store inside the row variable that we saw already. The same thing we are going to do right over here. It will pick up the very first index, the complete first row, that is a list, and will store in the variable s. So that's what the first portion of the statement is all about. And now let's come to the decision making. Once s contains the very first row, now we are going to check, and this is the if part that comes in picture, that whether if the value 5 that I want, is present in this row or not. So this portion will traverse individual item wise and see whether 5 is there in the first list or not. The answer is no. After traversing all the item of the first row, it is not there, right? Okay, then moves on to the second row. So again, from the main object, it will pick up the second list, and that will be assigned to the variable s. And now after assigning, it will come right again over here in the if statement. So this is the if part, you can think so. So if this item is present in this row or not, yes, this time 5 is there. The moment 5 is there, over here I'm writing any. The moment 5 is there, it will say yes, it's true, it's there. So it will assign true inside the exist. Now still we are left with one more row. What do you think? The process will continue or it will terminate right over there? Well, it would have terminated provided I wouldn't have written this third bracket. So this third bracket implies that this is a list comprehension and not a generator function. Well, generator is a concept. I will tell you. As you can see over here, the same thing I have replicated, but the only difference is that I have written within the parentheses rather than within third bracket. Since I have wrapped up within third bracket, there is a big difference this time. Since it is a list comprehension, so it will not stop right at the one index, rather it will move to the second index as well. So from the second index it will pick up the entire list, and that will store right over here, and then we'll perform the if decision making statement over here to check whether the value 5 is present in this particular list or not, and the answer is of course true as well, and that will be stored inside the exist again, or better to say it will override the previous true. And finally what you will see in the output is the answer is true. As you can see right over here, does 5 exist in any list? The answer is true, it does. That's the reason I said over here the two important catch that you need to keep it in mind is that since I have written this entirely within the third bracket, so this is not a generator, rather this is a list comprehension, and since I'm writing any over here, so it will store just only one time the boolean value true. It will not store multiple true as many times it get matched. That means number of true won't be there, rather it will just be only one, and that's the reason you are seeing over here one time true. But if I want to replace this entire list comprehension into a generator, what I need to do, you just don't put the third bracket. It would be exactly the same, just put it within the parentheses. So here are the same thing. At the 0th index it will pick up the first inner list, and then it will perform a if condition checking over here, and if the answer is true it will store true over here. But in the first list there is no value 5, so it will move to the second row. It will pick up the second row and it will store inside this, and then it will go for if decision making, and it will find the answer is yes, 5 is there, right. Here comes the difference between a list comprehension with the generator. Since it already got the value true, it will not proceed to the next row. Please keep it in mind. In case of generator, it will not proceed to the next row once it finds the answer to be true. This is what the default behavior of the generator is. Usually generator is called as a lazy behavior because it stops right over that very moment when it encountered the answer as true, because it believes that what's the point of checking, because I already got one true, so let's not consume the memory further. So it will stop right over there. And to show you that it's a generator, I printed this reference type, I mean what type of data it is, and it's showing that this is a class generator. So remember, this is not a generator. If you print the data type of this, it will show you a boolean first of all, but again if you just print within the third bracket it will show you a list comprehension, and this is what will show you the generator because you are not writing third bracket. Well, to explore a little bit more about generator, I have written a small code snippet over here to illustrate a bit more about generator, because this is often an interview level question. Let me show you what this list the generator is doing. So over here, as you can see, a for iteration is there. So for x in range of 5, so it will work from 0 to 4 because range will not include the upper bound, so 0 to 4. So that means it first time when it is running, the value of x is going to be 0, and then we are going to multiply 0 with 2, so that will make it 0, right? Again it will go and it will make the value as 1, and it will be 1 into 2, it will 2. Again it will go up, 2 into 2 will be 4, 3 into 2 will be 6, and 4 into 2 will be 8, and it will stop right over there. Okay, it will not go up to the upper bound. Fine. Now if you are wondering that if I print this gen, you will be getting all this 0, 2, 4, 6, 8, you are wrong, my dear friend. It will not print those values, rather it will print an address. Let me show you this. This is very important part. It will show you the address where this gen object is located inside the stack memory. It will not print those values which you are expecting. So how do you get across those values? Yes, I do understand that. I will show you how to come across those values, but before that let me show you. So this here I showed you the type, that this is of the type gen, right? This is what the thing goes. So now let me comment this portion once, and let me delete the comment. Now what I want to show you, that how do I get the value of which got generated over here, and for that reason you have to use the next function. The next function over generator will print you one value at a time. I repeat, it will print you one value at a time. So as you can see over here, it is printing the very first value. Let me run the code. So it's printing the very first value, that is 0. So each time you give a call to the next, it will print only that value. That means it will not print the value as a whole, and I already said the generator is like a lazy in behavior, so it will not consume the entire memory like what will happen in case of list. It will not store the value in upfront. As you call it, then only it will generate, and that's something very important as far as interview question is concerned. Remember this, in case of list comprehension, it will store all the values upfront. So that's where the memory somehow is getting blocked, because you are storing the entire value at the very beginning. But what generator function does is that as you need, it will execute on the fly. So it will not generate the value upfront. That's the reason if you call next only one time, you're going to get 0. The next time you call, you are going to get 2. The next time you are going to call, when the value is 2, when this was a 0, when it was 0, and when it is 1 it is 2, when it is 2 it is 4. See, I didn't stop, I didn't print the next again. So so for that reason you are unable to see the value 3, that is 6, and neither you are seeing the value 8 when it is 4. So that means in case of next function, invocation will print only on that very moment. It will not print all the value as a whole. Right? Okay, great. And what if I go and print again this time? Since you have already printed the value and it is just pending with 3, that is 6, and 4, that is 8, that's the reason you are able to see only, let me run the code, it will printing only those 2 values left over, because it has already consumed those 3, right? Okay, but what if I don't print this time? Let me close this one, and now if I print, let's see what happened this time. In this case, it will show you all the value as a whole. So it remembers, it keeps a track that just because I have printed all this thing up front, then when you are printing this kind of statement, it will print only the leftover thing. But yes, if you are not giving a call to the next function, and if you are printing them individually with the help of iteration, then it will print the entire thing. So as you can see, this is 0, 0 into 0 is 0, 0 into 2, 0 into 2 is 0, 1 into 2 is 2, 2 into 2 is 4, 3 into 2 is 6, and 4 into 2 is 8. And upper bound is not inclusive. That's the reason 5 into 2 has not been shown over here. So keep it in mind, when it's generator, it is a lazy in nature. It will print only as you call the next function. Otherwise it will not print, and if you directly try to print a generator, it will just print the address where it is located. I believe this is more clear than before, right? And lastly, we come to the topic of flattened view. Well, as we saw over here, when we are printing the individual row index wise. But what if I want to print all these items independently? And that brings us to the flattened view. Well, flattened view is not going to show a single row of list. That's what it will not do. Rather, it will print the item that is present in the inner list. Okay, let me run the code. It will be much easier for you to understand. Look at the difference between this. Here what you are doing, at the 0th index you are printing the entire row. At the 1 index you are printing the next row. At the 2nd index you are printing the 3rd row. So this is not flattening. You are printing the entire list index wise. Flattening comes as you have the actual object, you store the first row in this row variable of the index 0, and then you are going for traversal again. So from the first row it will pick up the first item and it will print over here, and there is a delimiter, as you can see the space. Then again it will pick up the second item for the first row, printed over here, the third item printed over here. After you have consumed all the item in the first row, it will go up once again and it will print the second row of the index 1 and will store over here, and then it will traverse all those items, and this is called flattened view. So it is not going to print your entire list index wise, rather it will print all the item that is present in your complete list. Okay, I believe from this particular video you realize that how important to perform all these operations, because these are very tricky questions that are often been asked in interview, so that you don't get confused at that point of time. Do check this video as many number of time, do practice as many number of time, because there is no alternative of practicing. Okay, so that's all from this video presentation. In my next video I will be talking about list of set and tuples, and they are going to be really exciting. So keep watching my video. Until then, have a nice time. Bye bye.